Looks like we're getting ready for another Monday of snow. So I'll use my time well, I think, by developing this test on Chapter 4 practice to give you an idea what you might expect. So, as you recall from Chapter 3, what we said we would be doing is when we have a graph and you have one line like so, and another line like so, and you have a point here of intersection of these two lines, which are a representation of graphs or of equations in their graphic form. This ordered pair is a solution for both of these equations. And we say we have solved these equations simultaneously. And one of the methods we'll use is graphing. But to start us off, what they want us to do over here is to see if in fact this is a point that would solve each of these equations. So the strategy for doing it is to replace the x here with a 2, and it's minus 2, and then the y with a 1, and see if that equals 4. And then we do the other one, 3 times our x, which is 2, plus 1, whether that equals 5. Well, as we see here in this first one, this is going to be 2 minus 2 is 0, so that does not equal 4. And this is 6 plus 1, that's 7, so that does not equal 5. So the answer to the first one is no. In this next one, again, it's replacing the x with 2, the y with 1, and that does check. The x with 2, that's 4, minus a 1 is 3, that checks. And we'll do this one live here. So our x is 1, our y is 4, so 2 times 4 is 8. Does that equal 5? Well, you don't have to go on. Once you see something like this, that's going to be a no. You could do the other one, but it doesn't make any difference. All right, so the point is here, this would be a point of these two lines. This would be a point of intersection, a common solution to both of these. All right, let's go on. Because now we're going to recall our skills from the previous lesson and graph each of these equations to see if through graphing we can pick out a solution for both equations. So since this is in slope-intercept, let's plot the -1 right there. Now our slope is 3 over 1. So we're going to go over 1, up 1, 2, 3. Over 1, up 1, 2, 3. Over 1, 1, 2, 3. This way it helps me make the line. And we'll see if we line all these up here. Okay, I'm off a little bit. When you do it in MATLAB, it does it very well. All right, we'll do this next one in blue. Now our y-intercept is a 3, so 1, 2, 1, 3 right there. Now our slope is a negative 3 over 1. So I'm going to go 1 over this way and then up 3. 1, 2, 3. And I'm going to go over 1, 1, 2, 3. So again, I want to get a nice line here. And that's the thing about graphing. It's when it's a fraction, it's not on a grid line. So let me study this a little bit. Now, this one is ending up with a fraction, because I double checked it using one of our other methods down below. So as we look at this, what seems to be the ordered pair? Well, the y is quite obvious, a 1. But our x is right about there, 2/3. So again, it proves that graphing isn't always the best method when you get fractions because it's hard to pick it out. And you may have to use another method if it's you're not sure just where that point is. All right, well, let's look at technique over here a little bit. And here we see that the equations are in standard form. So let's use our x and y intercept t-chart for this. This will be 0 and 0. So if x is 0, y is a negative 4. And if y is 0, x is going to be a 2. If this is 0, we're dividing both sides. And I'll change color here. Now for this one, if x is 0, this is kind of a hard one to do because that's a negative 8/3. And again, they're giving us some really hard ones to do. I think they would make it easy here. Then if y is 0, our x is going to be 4/3. So let's check our work. Our first one came out very well. This one, if x is 0, we're just dividing both sides by a negative 3. Gives us that and that. Okay, well, let me try to graph these. Okay, this first line was rather easy to draw. That's the red line. But when I converted these to mixed numbers from their improper fraction, I put that there and that there. And lo and behold, what am I getting? Well, I'm getting something that looks like this. And what does that look like to you? Ah, these are parallel lines. So for number 5, there is no solution. All right. Again, graphing can be challenging, but it sort of shows the process of what is going on. All right, let's go on to algebraic methods now for solving these. And when you take your test, you're only going to get a few of them. You're not going to get like 20 or 25 examples, whatever is on this test. So you just want to know the method of arriving at a solution. So as we look at number 6, and they're asking us to solve it by substitution, how do we use substitution here? Well, we had said you solve for one of the letters. We say x, we're going to transpose the y to the other side, and we get a positive y now, minus 2. So there's our value of x. We then take this value and put it where the x is. That is, substituting what x is in terms of y. So we now get 2 times y minus 2. There's our x value right there through substitution, minus 3y equals. So continuing, negative 8, we then clear our parentheses. 2y minus 4 minus 3y equals a negative 8. And then we're going to group like terms. 2y and a negative 3y gives me a negative y. I'm going to take this over to the other side. Becomes a positive 4. A negative 8 and a positive 4 gives me a negative 4. Now I have negative y equals negative 4. Divide both sides by a negative 1. I get y equals 4. So if y equals 4, I can put that 4 right there. 4 minus 2 is 2. So my ordered pair for number 6 then would be 2, comma 4, and I found it through substitution. Okay, we're not going to do every single one because I want to just show you the process here. So let's do number 8. So number 8, they already solved it for the letter y. So here we're going to go 2x, and this value of y is going to go right there. 2x plus 3x minus 2 equals 8. So this is what we said y was, 3x minus 2. So we're replacing that y with this. Now we only have one letter. So this is going to be 5x minus 2 equals 8. We're going to transpose that negative 2 to this side. It becomes a positive 2. So we have 5x equals 10. X equals 2. So we take this 2 now and put it there. So it'll be 3 times 2 is 6. 6 minus 2 is 4. So we get y equals 4. So our ordered pair, and let's see here. For that one was a 2 and a 4. Okay, I guess I erased it here too soon. All right, that's substitution. Now, there are other methods, as we said, and we're going to feature that right now. Now, when you see something like this, and they're saying to solve it by substitution. Uh, Sometimes you might have a little wiggle room, and this one in particular, rather than solve it by substitution, we could use this technique of addition. And again, knowing all of the methods is what would be useful to you. So for instance, in this one, as we put our line there, we see that these just cancel out if we're going to add them, and we get 5x equals 15. Divide both sides by 5, x is going to be a 3. So if x is 3, we have 3 times 3 is 9, plus y equals 5. Initially these canceled out. We got 5, 15. Divided both sides by 5, we get x equals 3. If x is 3 right over here, 3 times 3 is 9, plus y. Now we're going to transpose the 9, get a negative 9. So this gives us y equals a negative 4. So our ordered pair then for 10 is 3, negative 4. Now you might say, well, they told us to do it by substitution. But there's a little wiggle room. And when you're doing your work, you want to use a method that's really obvious here where something will cancel out. As we see in number 11. Notice these just cancel out. So this gives us a 4x equals 8, x equals 2. If x is 2, we can use either equation. Use this one. 2 plus 2y equals 2. Notice the 2's will subtract out, and we get 2y equals 0. So y equals 0. So our ordered pair for number 11 is going to be 2, 0. Now I should mention that there are times when, as you do either substitution or addition method, you're going to end up with something like this. You're going to say that 3 equals 5. And we know that's not true. Well, when that happens, you have a situation in which your equations are actually parallel and there would be no solution. We had one of those in the graphing. There'll be other times when you end up with something like this, 3 equals 3. Now that is a true statement. So what is your solution there? Well, as we had mentioned, these lines are going to be the same lines, and you will have what we call an infinite number of solutions. And then you usually write your answer in x comma y is such that, and then you write out one of the equations. Now the other one looks different initially from this one, but actually it's the same equation. It's just an equivalent equation that's either been multiplied or something added to everything so that it doesn't quite look the same. But when you boil it down, it's the same equation, and that's how you would indicate that. So let's do some of these others. Again, we're not going to do them all because you're only going to have sort of one of each type on your exam. Let's do number 12 as a typical one that's sort of a challenge. And what's our strategy here? Well, again, we don't want to have fractions. So we're going to multiply everything by 4, the common denominator, to get rid of all these fractions. So here the 4's cancel out, and I'm left with x. 4 cancels out, and I'm left with a plus 3y. And here I'm left with an 8. So this original equation and this equation are equivalent. The values of x and y are the same. And here we're going to also use 4 for every term. But now here we're left with a 2. Here the 4's cancel out. So we have now a 2x plus y equals a negative 4. And it's good to check your work because any little mistake you make, sign or multiplication, because you don't get the right answer. So we double check that one's pretty straightforward. This one we're going to multiply everything by 4, 2y. Yeah, that looks good. But now when we want to add something here, nothing's going to cancel out. So if I take that first equation, and this is the artisan or the artist way of doing things, I'm going to multiply every term in this equation by a negative 2. Why? Because now, and I'm going to write this one under this new one, I get a negative 2x. I have something that will cancel out. This is a negative 2 times this is a negative 6y. Now a negative 2 times 8 is a negative 16. So again, hopefully you're following. I had to get rid of fractions. I now am making this an equivalent equation, but something that will allow me to cancel out my x's. We're going to eliminate the x's by multiplying every term by a negative 2. Again, this is another equivalent equation, modified such that one of the terms will cancel out. So here I get a negative 5y equals a negative 20. Divide both sides by a negative 5, I get y equals 4. Now, I'm going to use one of these that are without the fractions here. So I have x plus 3 times y, which is 12, equals 8. I now have x equals, transpose the 12 becomes a negative 12 on the other side, and I get here a negative 4. So for number 12, my ordered pair is going to be a negative 4 and a 4. And if I were to put that into my original equations, that would do it. Now again, I'm not going to do them all because this tape is going to get to be too long, but what technique? Let's just go over techniques here. Now if you had this one, you want something to cancel out, you would have to multiply this equation, each term, by 2. This would make this one a 4y and a negative 4y. They would cancel out. Now this one here, you have to multiply each equation by something different. Here we're going to multiply this one, let's say, by a 3. This one by a negative 2. In fact, let's just write that one out here. Now as I do the first one, I get this. And as I do the second one, I get this. And then lo and behold, what happens here? Well, these cancel out. These cancel out. I end up with a 0 equals 16. Is that a true statement? No. So these lines are parallel because I ended up with a not true statement. So for number 14, there is no solution. The lines are parallel. Okay, going on to 15. As we look at this one, looks like the easiest way would be to take this bottom equation and multiply each term by a -2. Therefore, these would cancel out when this becomes a -2x, and the technique is continued. Now, you sometimes wonder, well, what method should I use? Well, here they're saying use substitution or addition. What would you use here? Well, I would think substitution because you have y solved already. Okay? And let's do that one, by the way. So here we're saying 2x. Now y is a -2x, so -2x equals 0. And notice what happens here. 0 equals 0. Ah. So in this case, if we were to solve for y here, transpose that, that becomes y equals a -2x. These two equations are the same. They're just in different forms. This is in standard form. This is in slope-intercept form. They're the same equation. So we ended up with a true statement. And what would your answer be? Well, for this one, it would be x comma y is such that y equals a -2x. You could have put that one, or you could have put this one. That's how that works. And I think I recall from one of the previous tests that they do ask you one word problem. So one number, x, is 2 more than the other number, y plus 2. And their sum is 8. X plus y equals 8. So here, this you can do substitution. Take this and put it where the x is and solve it. Now for number 3, not number 3, I was looking down here, there's 3 letters. Yeah, that's not it. How about number 20? Basketball tickets at a high school sell for $5 and $2 for students. So let's call this price X and this one Y. This is how much was made from the sale for one game where this many tickets were sold. Okay, so we know the number of $5 plus the number of $2 tickets. The total number was 270. And for the $5 tickets, that number, plus the $2 tickets, that number, the sale was 900. So again, you could use substitution or multiply here everything by a -2. I probably would do it that way. and then solve for one letter, then for the other. Because they want to know how many types of tickets were sold. You need to solve for X and Y. Number 21, how much solution? 30%, 80%, to make a mixture of this many of 60%. All right, we're going to call the 30% solution X, the 80% solution Y, and our first equation, X plus Y, equals the total amount of solution, 500. And we're going to have 30% of X, which is this, plus 80% of Y equals 60% of 500. So if you looked at the lesson we actually did on this, we went over these in great detail. But here on your test, again, you want the strategy of being able to convert from English into algebra and then put it into an equation. And you might say, well, how would you solve it? Well, first I'd get rid of all the decimals by multiplying every term by 100. And then again, use substitution or elimination. Okay, well, that was a review, and fortunately you don't have to do any of these with 3 variables. And again, it was sort of a review in preparation for your test. Right now it's set up as a combination test, 5 and 4. So you're only going to get a few questions like this, and then sum of 5. Good luck.